Good morning, everyone. Today we're going to be taking a look at our first optimization problem, and it reads as follows. The Student Council organizes a bake sale to raise funds for school and is looking to maximize their profits. Each donut generates a profit of 65 cents, whereas each muffin generates a profit of 47 cents. The council decides that they must sell at least twice as many muffins as donuts, and that they can sell no more than 250 items in total. What is the maximum amount of profit that the Student Council can make? Now, before we start to attack this problem, we need to figure out what type of information is being given to us. Well, we're told that each donut generates a profit of 67 cents, whereas each muffin generates a profit of 47 cents. So already we have some information there about profits for the items that we're talking about. Then it says that the council decides that they must sell at least twice as many muffins as donuts, and that they can sell no more than 250 items in total. Those are sentences that are telling us information about inequalities that we're going to deal with later on. Now, they're written in a complicated format. They're not written as a simple subject-action complement form. So we do well to pick out some of the information. So you have the action of being at least, and we're told that we're going to have at least twice as many muffins as donuts. So the subject of this particular sentence is the muffins. And we're told that the muffins will be twice as many as the number of donuts. So this can be rewritten in the simpler subject-action complement form. So if we look at our givens, and we decide that x is going to represent our number of donuts, and that y will represent the number of muffins, and we can rewrite the sentence that says they must sell at least twice as many muffins as donuts as the number of muffins must be at least twice as many as the number of donuts. Now we can continue along that sentence where it says that they can sell no more than 250 items in total. So again, they can sell no more than, and this sentence is talking about the items in total. So this will be the subject. And the complement of that particular sentence is that the items can be no more than 250. So again, rewriting this in the simple subject-action complement form, you find your second equation, where the number of total items, which means the number of donuts, and the number of muffins can be no more than 250. So we now have the two inequalities that deal with this particular problem. If we keep reading, it asks us for the maximum amount of profit that the Student Council can make. So in our problem, we are required to find the maximum profit. So it is essential for us to determine how it is that profit is calculated for this particular problem. And if we look at the sentence that says donuts generate a profit of 65 cents, whereas each muffin generates a profit of 47 cents, that tells us exactly how profit is calculated for this problem. So our profit P is going to be equal to 65 cents for every donut plus 47 cents, 47 cents, so 0.47 for every donut. And now you have your inequality equations, and you also have your profit equation, which ends up being your optimizing function. So now is the part of the problem where we need to put up some additional information. So this is going to our added section. And if we think back to the context of the problem where we're talking about muffins and donuts being sold, where X represented the number of donuts and Y represented the number of muffins, you can't be selling negative amounts of any of these items. And so we have two additional constraints that just come from the context of the problem, that the number of donuts must be a positive number, and the number of muffins that we're dealing with must also be a positive number. Now this is the case for most real-life situations. And so that restricts us to the first quadrant of our Cartesian plane. So we can neglect quadrants 2, 3, and 4. Now we should start putting up the inequalities that we're dealing with. So if we look at our first inequality that says that the total number of items must be less than or equal to 250, we can make a small table of values and we can graph this particular equation. Now, because it's a less than or equal to equation, it must be a solid line. So we can start by replacing x by a value. So if we choose 0, that means that the y value should be 250, because 0 plus 250 makes 250. And if we choose a second value for x, say 100, that says that our y value should be 150. Now, putting up these two coordinates onto the Cartesian plane, or maybe we should define what our axes scale is going to be. So if each square is 25 in both the x and y directions, that means that when x is going to be 0, y is going to be 250. So that means we need to go up 10 squares. So there's our first coordinate at 0, 250. And if we go to x is equal to 100, so that means we need to go down 4 squares along the x-axis. We need to go up to 150, which puts us 6 squares up. Okay, so once we have those two coordinates, we can just draw a straight line through them. Make sure you extend it just past the bounds of the Cartesian plane. And because we had the equal to sign, it must be a solid line. Now we must determine where the shading for this particular inequality is going to go. So you can just use a test point. If we use 0, 0 as our test point, we can test the inequality to see if in fact 0 plus 0 is less than or equal to 250. Now remember, here we're asking the question whether that particular coordinate satisfies the inequality. And as a matter of fact, 0 is less than or equal to 250. This is confirmed. And so the shading goes towards that particular test point. So there's the shading for the inequality x plus y is less than or equal to 250. We repeat the same process for that second inequality. And so we have y is greater than or equal to 2x. So again, you create your table of values, x and y, and you can choose some values of x. So if we choose 0 for a value of x, that means 2 times 0 is going to be 0, so our y value is 0. If we choose a value of, say, 100 for x, then the y value must be 2 times 100. That gives us a y value of 200. So again, plotting these points onto our Cartesian plane. So here is 0, 0. And here is 100, 200. We can connect these two coordinates with a straight solid line. And again, the solid line is because we have the greater than or equal to sign. So we can connect these two with a straight solid line. And again, just make it extend past the bounds of the Cartesian plane. Now that's reasonably straight. And again, we need to determine where it is that the region of the graph is going to be shaded. So you can use any test point you'd like. However, you must restrict yourself to a test point that is not on the line that you've drawn. So we can choose anything other than 0, 0 or any of the other points that are along that line. So if we choose 0, 50, because that one's not on the line, what we're going to do is we're going to test the inequality to see if in fact 0, 50 satisfies that particular inequality. So we would have 50 for the y. Now we're asking the question, is 50 greater than or equal to 2 times 0? And so if we look at this, 50 greater than or equal to 0, this is in fact true, it's verified. And so we must shade towards the test point. Now if we look at this particular graph, we have a region where all of the inequalities are satisfied. And so you can highlight that region for yourself just to make it more apparent. And now this region right here is our polygon of constraints, and our solution to the problem must be somewhere within this polygon or along its bounds.